All right. Hello to people who are joining us for the second of our design review live streams today. We are looking at features that will be going into Wolfram language version 12.3. And we had started previously looking at geometry and graphics, and we are continuing with that. So let's see, where have we got to so far? We were talking about material shading, is that correct? Have we finished material shading or not?
Unless you wanted to look at the namings
of options.
Let's have a quick look at that. I know what I realized is this weird spinning has something to do with 12.3, some 12.3 front end this year. Okay, so which option should I be looking at here? This is the
those are the parameterized model.
Okay, base color, coat color. Why isn't it coating color? I mean, it's like the thing's wearing a big fur coat or something.
Well, in this case, it's more generally the clear coat, right? You have on top of like a car paint, right? You have a clear coat, and then you have the.
I see. But how does it? I mean, if it's covering the surface, how do you see through it? I mean, there's no. I don't understand.
Right. So usually you have the material have the base color, right? And for a car, the car paint, then you have kind of in some case 3 layers, right? So you have a clear coat on top, and then you have the color, and then you have a primer. But in our case, we just have a clear coat, and then the base color. So the clear coat is, roughly speaking, transparent. It just have a reflection of the diffuse light.
Right. The coat color you're saying is transparent.
Yes.
But when is the coat color not transparent? And why doesn't the coat color just change the effective base color?
Yeah, it actually affects the base color. It affects the amount of light which reach the base color. That's pretty much it.
But you're saying that it affects light that is shining on the thing, does not get to the base color, it gets only to the coat color, is that right?
No, it's some of the light, not the full set. So the clear coat reflects some of the light.
Okay, in this picture.
We don't have the clear coat there. So we haven't yet completed. So what we are hoping is to actually have to remove the clear coat and the sheer color and have a second illustration, which show actually that additional layer you have on top. So we are still working with Tim on that illustration.
Okay. Okay. Well, these seem like reasonable names. What do you mean metallic values? And what do you mean roughness values? What does that mean?
Well, it's pretty much a numerical value which expresses the, roughly speaking, the degree of roughness or metallicness of an object. So 0, that means it's pretty much not metallic. And 1 is metallic. So the non-dielectric are, less than 1, pretty much.
Shouldn't it be called metallic and then some word that means parameter or coefficient?
Yes, you can probably say maybe coefficient.
Yeah, coefficient seems right. It's a coefficient because it can go with other things, presumably. Okay. Surface normals is a bunch of normal vectors, right?
Yes. So we name that.
When you say roughness coefficient, what does that, in metallic coefficient has to do with that sort of a bank switching of specularity and various other things, correct?
Yes.
Okay. Is coefficient right, or is there some other slightly more technical term? You know, metallic strength, or I don't know what.
Yeah, usually people just say metallic or roughness value.
Maybe we should call it metallic value. I just think metallic is a really weird option name when the value is 0.5. See what I'm saying?
If we call it roughness, maybe it should call metallicness.
Metallicity, that's what you call it for stars.
I see. I didn't know that.
What's the fraction of heavy elements in a star? Not relevant to this.
No.
But I mean, it isn't a roughness. I don't know what scale you would measure roughness. I mean, a roughness of 1 means what? I can have a roughness of 4. Charles, can I have a roughness of 4 or not?
Yes, so it's a numerical value between 0 and 1 also.
So you can't have a roughness of 4.
Oh, you can't. I mean, we can probably take it and then mod it to adjust it, but it should be a value between 0 and 1.
Why isn't it then metallic fraction or roughness fraction if it's between 0 and 1? Does that make sense? I don't know what these things are. I mean, they contribute obviously to some equation.
Right. So it's essentially kind of a coefficient in the equation of the computation of the light. Right. Depending on the specular light or the diffuse light, there is a coefficient, a linear coefficient actually in that equation, which is reflect the roughness of the material or the level of conductivity of the material.
So wait a minute. Okay, listen, what is the word that should go with it? Is it metallic fraction, metallic coefficient, metallic value, roughness value, roughness coefficient? What do you think it should be? Coefficient is sounding right for what you're describing right now.
Yes, especially that we in the technical document Alec is writing now. We should kind of show the equation is a coefficient term in that.
Great. Okay, we're done with that then. Specular anisotropy. Wait a minute. Is that a value from 0 to 1 or something, or what is that?
Yes. So that one is also a value between 0 and 1.
Okay, you shouldn't call it property here. You should just say anisotropy of specular reflection. Shouldn't you?
Yes.
Although, what does it mean, anisotropy? I mean, how do you measure anisotropy? Do you understand? I mean, the light is coming in at a particular angle, and it will be specularly reflected at some other angle. If the anisotropy is 0.7, what does that mean?
Well, again, I mean, 0.7 is since here is just like above, it's just a coefficient, right? People can use to vary to actually be able to reproduce that effect of light or simulate that effect of light. So it's
then you should probably show it specular anisotropy coefficient.
Right.
I think, because I think it's not, these are actual colors, right?
Yes.
And these are
so there's a big deal that's these people discuss, that they're big into sort of modeling lighting interaction. So they talk about physical parameters and artist parameters.
Yes.
And they very much dislike physical parameters. Because,
yeah, I understand.
Because they're not predictable what effect they have. And so they're striving for parametrizations that can be sort of predicted the effect that they have.
Yes.
And that's usually called artist parametrization.
I knew there was a need for such a term like 30 years ago. I didn't know a term had arisen. Yeah.
Right. Yeah. So these guys are, I mean, I completely understand where they're coming from. It makes perfect sense because you might have two that sort of co-interact and you can't really tweak one without the other. And it's like horrible.
Well, so specular anisotropy coefficient, do you have a problem with that?
No.
Okay.
No, the names are fine. I'm just saying that they're not as physical as you might think sometimes, because people don't really like the physical.
Right. Good reason to say coefficient.
Yes.
So ambient occlusion. Well, if it's the fraction, ambient occlusion fraction, is it physical or is it again an ambient occlusion? Ambient occlusion coefficient. Or is it ambient occlusion fraction?
Well, so in this case, the ambient occlusion, there is a fraction case which apply globally to the surface, but you can actually apply it, you know, per point on the surface.
Mm-hmm.
So it's a fraction of the light on the surface.
So wait a minute, wait. The value of this is like 0.7 or something, right?
Why? Between 0 and 1.
Okay. And so then, is it, okay, tell me what it does again. What does it do? Fraction of the ambient light on the surface. You mean, oh, okay, it's pretending that you're shielded from the ambient light.
Yes.
I see. Well, I mean, I think it should be called ambient occlusion fraction. That makes sense? Unless you think it can do without the fraction part.
Both work for me. I mean, people are usually just saying ambient occlusion. So, but yes, we can add fraction. We don't have so many options called, you know.
Let me point out that occlusion, if it's equal to 1, that means there's no ambient light. Is that correct?
Yes. Alex, is that correct, right?
I think in this case, actually the reverse.
Yes.
So 1 will
reverse.
all ambient light, and 0 will be no ambient light.
0.
Okay, so then the name is wrong. Because occlusion, you have more occlusion if the value is higher, which means that you have less ambient light contributing, right?
Yes.
So is there any other name that people use in the literature? Either that, or is this basically, is this the right way around? I mean, or should it be 0, 1 flipped around? We kind of need to know what people do in the literature. So come back with this, please. Go ahead. What were you going to say?
But I think maybe it's the concept, which is the other way around, because it's more how I expose a point, right, in the scene is to an ambient light. It's not per se the amount of ambient light, but it's how how I expose a point in the scene.
So if the value is higher, if it's 1, it gets all the ambient light?
No, they're saying it's the other way around.
But then it's correct. Then it is occlusion.
Yes. Okay, so wait a minute. If the value is 1, does it get all the ambient light?
Yes.
Okay.
Did you say yes or no? I couldn't hear.
Said yes.
Yes. Yes.
But it's the wrong way around. Then
it's the wrong way around. Yeah.
Yeah.
No.
But maybe we should change the order then. Of you should take 1 minus that parameter if you want it to be.
No, if you said ambient occlusion is 1, that means the point is fully exposed to the light.
No, but occlusion means, look, we're not ray tracing here. Occlusion, I thought it meant look, if you called it ambient exposure fraction or something, then what you're saying would make sense. But the occlusion fraction is it's in the light and it's making a shadow for something else, but we don't have shadows. So that's not really relevant, right?
Right.
But if you called it ambient exposure fraction, then that would handle it, then that would make clear that it is the extent to which it is exposed to the ambient light, which is kind of what you're going for also with this occlusion idea, except that the occlusion idea makes more sense if the thing is going to, cast a shadow or whatever. Does this make sense?
Yes, we kind of dig more in that. Yep.
Okay, so ambient exposure fraction. Make sense?
Yes.
Okay. All right. Question from the live stream from Ethan. Will be able to specify shaders for materials in top-level code. And there's currently support for GLSL code strings. What is GLSL?
It's the shading language in OpenGL.
Ah, okay. So what's the answer? Will there be any way to specify shaders from top level?
Not at this point. So we hope in future version to actually be able to import it. We are still discussing that shader language in general.
Ultimately from compiled code or something.
Well, first of all, we want to be able to import this MaterialX because that's more composite, well-designed material. So I'm saying you need the shader language is very low level. So they've created a higher level language, which is this MaterialX modeling language, effectively,
okay.
which uses these transfer functions, these reflectance and transmission transfer functions, effectively, or really approximations to those. So then you can design all kinds of layered material. And so we want to be able to import those kinds of specs and maybe even export them, those kinds of specs.
Okay.
So then we can coexist together with other digital content creation software, both CAD software and a sort of game software.
Yeah, I understand. Okay, so MaterialX is, so when you import that, you will have something that is called essentially, will it look like material shader of file of blah? Or no, it has to have some serializable version. So it has to have some kind of symbolic representation of that imported. Actually, you know what? We have this new notion of an imported object. Or no, what is it called? Yeah, I think that's what it's called. Imported object that we're using for things like PEM files, where there's some random piece of external gunk that is basically only relevant if you feed it back to the outside world. You see what I'm saying?
I see.
So that would be the relevant thing, an imported object.
In here, I'm not 100%. I don't know enough whether we've sorted everything out because we use different rendering systems on different hardware. So, like Apple wants to use metal, for instance, and
yeah, I understand. I understand. So the import, but I mean, this is the same as the compiler. The situation we have with the compiler, right, where it's generating code, and now we have a version where it serializes for all the different platforms, and it just uses whichever serialization is relevant. But if you tell it, okay, when you first do the serialization, when you first create the compiled code function, you will be able to tell it what target systems you want it to be set up for. If you say target systems to all, then it will try and build, the bag of bits for all the systems we support. And then for any specific system, like a Windows machine or something like that, it will, if it is read back in, it will rehydrate just the Windows version. Does that make sense?
Nice. Yeah.
So, I mean, this would be presumably the same kind of thing. And in that case, for some kinds of extremely, close to the metal things, we will have compilation as a service where it works through the cloud. to compile for all those platforms, because it actually has to send it to actual machines with actual libraries running on them and so on to get the final bag of bits, so to speak. But fortunately, we figured out a way to do that using LLVM intermediate code that doesn't require one to go all the way. It doesn't require one to do that compilation as a service. So I don't know what exists in this case between these different.
We have a little bit more work to do, so I don't really want to.
Okay, fine. All right, sounds good. This looks great. Epi on our live stream is commenting that ambient occlusion is the technique, the exposure is the value at the point. So the exposure is what we are recording here, right?
Right.
Okay, good stuff. Well done. Anything else on material shaders? Material shading, going once, gone. Okay, let's continue here. Graph layout. Oh, good. We've got method pages for those now. Is that what you're telling me?
Yes.
Don't forget, by the way, I'm sorry, don't forget that you need one of those. If you need a guide page for the methods and you need a list of graph layout methods thing in the documentation at the top, right?
Right. So we are still working on that actually.
Okay. All right. So can I click on one of these and see the page?
They're probably not linked.
Not linked.
But you can open one.
Spring Electrical should be probably an example.
Okay. How do I open it?
I think that this one doesn't have any DocuTool support yet to do method pages. I think that we probably want to get that now because we have several teams working on it. So you have to bring up.
Okay, this is too complicated. If you want to send me a page, you can go ahead and send me an email with a page. Okay, so what all should I see? So the main change here is just documentation. Is that correct?
Yes.
Okay. When do we get things like hyperbolic layout?
Oh, that's also there. If you go slightly farther down.
Oh, cool. Where? Oh, there we go. Cool, cool. I want to see that. Okay, hold on. Okay, so let me say, oh, this is really cool. Am I going to be excited by this, or is it going to have some horrible problem? Okay, so let's say I have a carry tree.
Still under development.
Okay, well, there's the carry tree. But now if I say graph of that graph layout, arrow, it will be just, well, I guess it doesn't, hyperbolic, right? What is it called?
Hyperbolic embedding.
Wow. What happened?
What version are you? Is it
Yesterday. You want to share, or do you want to send me a notebook where this has been run?
But myself, I complete have a new build, so I will try something.
It is a graph, not a graph 3D, right?
Actually, try maybe the 3D. Maybe we haven't done the full embedding yet.
No, I mean, it's just not working.
Hyperbolic. I just want you to work on my build.
Well, just send it to me, okay? Are you sending it to me or not?
Yes. Send to.
Okay. All right. Okay.
Okay, send.
Okay. I assume layered graph plot 3D comes with, I mean, that's the equivalent of layered digraph, graph 3D of layered digraph embedding. Is that correct?
Yes.
Okay. What happened there? What happened there? Can you hear me? I mean, what is this? Charles, are you there?
Yes. 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 So it's those parts we are still, working out, because there is right now we are not sorting the edge to, to allow those passing on crossing so that it lay correctly in the space. We are just purely embedding the point. So that's why I say it's still under development. So we are working on actually that whole aesthetic side and make sure everything is,
Okay. Is there a parameter to the hyperboloid, so to speak, to the hyperbola, or is there a parameter that determines? I'm a little bit unclear. What? Isn't there some curvature parameter here for the curvature of the space?
No, in our case we don't.
But
So we
don't you
assume
need that? Go ahead.
So in our case, we assume you are on the Poincaré disk, and essentially what we do is we run the spring electrical and try to force the point to satisfy the constraint on that space.
Okay, but I think that has a parameter. I mean, I know the Poincaré disk itself does not, but there's a question of kind of, if you imagine, one of those Poincaré disk things, that's kind of like how clumped up is it at the boundary? That's a parameter, which is essentially
Right.
the curvature, I think.
Yeah, so we probably pre-assume that, so I can probably check more and and have that parameter.
Yeah. Okay. Cool. All right, let's keep going. All right, so graph constructor illustrations. Lovely. Find, click, and so on. I'm sure that's useful. Are you putting these on the guide pages as well?
Not at this time. I think we should eventually do what we did for our BIS pages.
Yeah.
So we created this new constructor for guide pages that goes through the build system to allow us to have visualizations. Or icons basically in there. But it's a big development project in its own right to do. So we're doing it.
Named labeled. Why is it called named labeled?
Yeah. Have you have a better name? So
we have index labeled, which was actually when we introduced you, was under your request. And so now,
okay, so let's say I don't even index labeled. Okay, well that's nice.
Well, here the index match with the name.
I understand. So that's not very exciting. Well, named labeled is clearly wrong. It might be name labeled. Am I making sense?
Yeah.
Didn't tell what I'm saying, because I mean in graph, if I say vertex labels arrow and it's called name, right? Do you understand?
Yes.
So I mean that's what confused me. If it said name labeled, I would have understood it what it was.
Okay.
I just didn't understand name labeled. And obviously the autocomplete for the plot theme has to include stuff like this.
Yes.
Seems good to me. Okay. Find spanning tree from list of coordinates, presumably returning the coordinates again, right?
Well, yeah, it computes the Euclidean spanning tree. So essentially, the spanning tree with the smallest.
I get it. I understand. I'm asking if you give it a list of coordinates.
It
returns you a graph with those embedding coordinates.
Right. Okay. But what was it doing? I mean, find spanning tree before
didn't work for a list of coordinates.
Yeah, it was just taking a graph.
Right.
I see. So if I say find spanning tree of geoposition, geoposition capital cities in Europe. Interesting. So now that, okay, so now if I say, don't we have this geograph thing now?
Yes.
What can I type here?
Geograph plot of that. Sure.
Okay. How come?
Yeah, you probably should.
Are those geopositions not preserved, or?
Well, they should be.
Well, I think it's a constant. Those geo positions are probably written as annotations.
Well, I think you've got something to figure out here.
Yep.
But I mean, what's it doing in the layout here? Like if I say vertex coordinates,
right, so this layout, it's
how do I get the vertex coordinates out of this?
Graph embedding.
But then I have to specify, I see graph embedding at %8, comma 2 dimensions, yes?
Yes.
Okay, what's going on here?
Well, what do you mean, comma 2?
Oh, it's comma the projection and comma 2. Yes, the embedding and comma 2.
Oh, I see. Okay, so this, there, those are geopositions, except they're not.
No, they are not actually geoposition. They are just position from a spring electrical embedding. We don't
It's one of those NACs or whatever those things are called. What are they in Peru or something?
Ask Lawrence.
Oh, okay.
We don't really have, okay, so we don't really have graphs and geo interoperating. That's something we need to figure out more fundamentally.
Fair enough.
I mean, there's things that you can accidentally make work if you do vertex replace. But the fact that that works is,
well, it's
more
only
an accident.
Barely works, right?
I mean, it's more an accident than
okay.
Designed to work.
By the way, Bob asked, have we added the new Icelandic volcano to geodata? The answer is probably yes. This is completely the wrong group to be asking that of, but somebody should send. I think I heard Yazabel there. Maybe you could send mail and check that.
Sure.
That would presumably go to Alan or Francisco or somebody.
Charles, you were trying to say something?
No, I mean, that should be close, right? I mean, that's an expected feature of the spring electrical. Right? You'll be close to the real one, but you will not be much in terms of length.
Well, wait a minute. You told me that the spanning tree on coordinates would preserve the coordinates. In other words, it generates the topology of a spanning tree, but it still preserves the actual coordinates of the original points, right? In the case where I feed in coordinates, it should be returning this with the coordinates being the coordinates of the original points, right?
Yes, if they are coordinating Rn, we didn't guarantee.
I understand. How do I get the coordinates from geoposition? Do you know?
No.
I know this will work, but it's kind of hacky. Find spanning tree expects a graph, except it doesn't now expect a graph, so you should change that message. Do you understand what I'm saying?
Yes.
Oh gosh, there's a way to get these out from geoposition that I've now forgotten. Okay, here we go. So now if I say find spanning tree, okay, and now if I say for that, right? Now I'm saying graph embedding of that. Oh, it's not going to be very useful. It's just going to put those back in. So now I just don't know which city is which here, right? That's a spanning tree of the cities in Europe. Probably, I'm guessing that's been flipped around. But I don't have any way to plot this, do I? Or does GeoGraph plot this?
I mean, it needs geo coordinates. I mean, geo position and so on.
You know what? It should default GeoGraph plot. If you give it something that just has pairs like this, it should assume their geopositions. Why not?
Okay.
You see what I'm saying? And then, because that will give us some interoperability even before we have the full thing. Why is there no raft coming up here? That's some other bug. See that? Anybody see that? That one.
What is a raft? Oh, that
raft.
Okay.
And by the way, 2 bugs. That raft has its lower, one of its sides is missing there. See that? If you screen capture that. Hear that? Anybody do that?
Yes, yes, I did. I did.
And down here, for some reason, there's no raft coming up at all. No idea why. It's probably a bug associated with this thing right below it. Either that or there's some other issue. Oh, you know what it could be is that this function is not yet somehow in some table. Yeah, look at that. It's not there.
Yeah, it's still futurized.
Okay, that's the reason it didn't have a raft. Okay. Yeah, this should work. Right. Displays the graph G with vertices at geographic locations on the map. If those vertex names are geopositioned, then it should work. And if those vertex positions are like this, it should work. Make sense?
Yeah.
Okay. Vertex in component. What does that mean?
It's a Stephen request.
Oh, vertex in component graph, the graph as opposed to, yeah, I don't understand what you mean by graph value from. It doesn't have a value. It's just a list of vertices otherwise. This is the graph that represents its in component.
Yeah, that's what I'm saying. The graph, the value is a graph.
Graph value. I didn't understand the phraseology graph value.
Right, like, sorry.
Okay. Vertex transitive graph Q, great. Edge transitive graph Q, terrific. Okay. Oh, really? Well,
so this hasn't made it in yet. This has not made it in yet. The basic research has been done, but it has not been. So here's the thing. With the asymptotics for number theoretic functions, we've been trying to do sort of a multi-stage, multi-phase project, and we're trying to curate what's there. It's not as impressive as you think of what's known asymptotically.
Hold on. How do I get a progress monitor? Can I do much bigger ones here? Like 10 to the 15? Wow. Is that using the asymptotic behavior of the Riemann zeta function? Guys, do we have the person who knows about this here?
Yes, I'm here. You mean if it use well, yes, the technique use it, but not explicit in that sense.
Okay, it says progress monitoring, so I'm looking to see progress monitoring, and so far I'm seeing progress.
So right now it's not on by default. So if you add the option progress monitoring goes to true.
Okay. Well, right now it's also uninterruptible as well. See that? This is uninterruptible.
Yes.
So that's wrong. So I have to kill the kernel here to get this to work. Up, finally aborted. Okay, so if I said 10 to the 16, why would you have progress monitoring off by default if it's progress reporting or what?
Progress reporting.
To true?
Yes.
So that's not an actual option name yet. Or is it an option name for other things?
No, it's not yet.
No, is it an option name for any function?
No, as far as I know.
Okay,
no.
so you can't put this in for this, okay? Because there's a whole bunch of functions that are supposed to have things like this. Right, so please ask the people who've been working on the progress monitoring stuff.
Yes, we discussed with them.
Okay, so this is what they want. So this is going to be put into like 50 functions.
Yeah, they pick the same name. I mean,
Can I see the list of functions it's intended to be put into?
I should probably ask Julio. I don't have it. Or Itai.
Okay.
I mean, those are the
Fine.
two.
So get that. Make sure that that's in a meeting, maybe an LCC meeting. Be there, and let's talk about this. Make sense?
I'll make sure it gets added to the agenda.
Okay. So I'm sorry. Let me see this again, just for fun. What is this doing other than just saying, I'm computing? So it doesn't know the remaining. Is it ever going to know the remaining time?
Yes. So there's first what I call the one mean time, where we kind of first estimate how much operation will have to be done, the algorithm, and then after that, then it start to estimate that. There's still some issue in terms of drawing the progress reporting bar and parameter. So
how many waypoints are you storing by default? I mean, why don't you store the 10 to the n points by default?
yes, so that was one of the things we're considering, because
I would store the 2 to the n and the 10 to the n by default. Do you see what I'm saying?
Yes.
Are there any other obvious ones to store? I mean, obviously you can, given that you have those waypoints, if you say 10 to the n minus 1, it'll be trivial to get to that one, right? Presumably that's how you do it.
Yes, pretty much.
Okay. Somebody's asking, Timos is asking, are those graph infos manually input? No, I mean, this is all from our knowledge base of many things. Okay, I think, let's see. Yeah, Bob is observing that you can use shader languages to do even neural net computations. Yeah, we're aware of this whole weird evolution path of GPUs and the like. Okay, anything else we need to cover here?
Nope, I think that covers it.
Okay, great. So this area is good to go for 12.3. Is that true?
Yep.
Excellent. All right. Will I see you again, Roger? Let's see. I think I have another design review in 30 minutes after a different meeting.
Yep.
So it's our day today. Right.
It is.
In there.
Yep.
Okay. See, and to people who are watching this live stream, there'll be another one starting in about 30 minutes. So hope to see you then.